Episode 9. Every prompt you have ever written was a guess. DSPy ends that. Instead of handcrafting prompts, you define your task as a program, and DSPy compiles the optimal prompts automatically by testing and learning from examples. This is the most important framework shift in AI engineering right now. Let's go. Welcome to episode 9. Let me describe something you have definitely done. You build an AI feature. It works okay, but not great. So you spend 2 hours tweaking the system prompt, changing the phrasing, adding examples, moving sentences around. Maybe it improves, maybe it does not. You ship it, and 2 weeks later, someone changes a model version and everything degrades. You go back to prompt tweaking. Round 2, this is prompt engineering by intuition, and it does not scale. Here's the fundamental problem. Your prompt is both the specification of what you want and the implementation of how to get it. Those two things are tangled together. Change one, you break the other. There is no way to automatically test whether your phrasing change actually improved things. You are just guessing and checking. DSPy from Stanford's NLP group separates these two concerns completely. You specify what you want as a typed interface, what goes in, what comes out, what the reasoning steps are. DSPy handles how to get it through automated optimization. Your program is no longer a blob of prompt text. It is a structured Python program that DSPy can inspect, test, and improve. The core abstraction is the signature. A signature is a typed declaration of your AI task. You define it with a docstring and annotated input-output fields. Here is what it looks like. You write a class called question answering that inherits from DSPy.signature. The docstring becomes the task description. Answer the question based on the given context. Then you define your inputs and outputs as class attributes with DSPy input field and DSPy output field. Context is an input field. Question is an input field. Answer is an output field with a description, a concise, factual answer. That is your entire task specification. No prompt wording, no formatting instructions, no few shot examples yet, just the interface. Now you compose signatures into modules. DSPy.predict wraps a signature and makes a single LLM call. DSPy.chainofthought wraps it and automatically adds chain of thought reasoning. It tells the LLM to think step by step before outputting the answer field. DSPy.react wraps it and gives the LLM access to tools, running a reasoning action loop until it can produce the output. This is how you build a RAG module in DSPy. You create a class called advanced RAG that inherits from DSPy.module. In the initializer, you set up your retriever, a DSPy.retrieve that fetches the top 5 passages. Then you set up your generator, a DSPy.chain of thought, using a question answering signature. In the forward method, you call the retriever with the question, collect the passages as context, and pass both to the generator. That is the full pipeline. But here is where DSPy becomes genuinely powerful. You have a data set of question answer pairs, maybe 100 of them. You split 70 for training, 30 for validation. You define a metric function, a Python function that takes the expected answer and the actual output and returns a score. For exact match, it is simple. Did the answer match? For generation tasks, you can use LLM as judge here. Then you run an optimizer. The most commonly used one is bootstrap few shot with random search. You give it your RAG module, your training set, your validation metric, and a number of candidates to try. You call compile. DSPy runs your pipeline on training examples, inspects which examples produced good outputs according to your metric, selects the best ones as demonstrations, and searches over different combinations of examples and prompt variations. What comes out is a compiled program the same RAG module, but now with optimized few-shot examples automatically selected and injected. Not examples you chose, examples that were proven to improve performance on your validation set. DSPy picked them by actually running experiments. In practice, DSPy optimized programs consistently outperform hand-tuned prompts on the same task. Stanford's original papers showed 20 to 30% improvements on NLP benchmarks. Production engineers using DSPy on domain-specific tasks report similar gains, with zero additional prompt engineering time after the initial setup. Here is the complete DSPy setup with the most powerful optimizer available. Start by configuring your language model. Call dspy.configure asset lm to dspy.lm using the model name. OpenAI GPT-4o Mini for cost-effective optimization. OpenAI GPT-4o for maximum quality. Also set your retriever model. If you are using ChromaDB, create a custom retriever module that calls your vector database. DSPy has built-in support for Colbert, Qdrant, and others through its retrieval module system. Define your signatures for a multi-step pipeline, search, synthesize, answer. You might have 3 signatures chained together. Assess relevance, checks whether retrieved passages are relevant. Synthesize facts combines passages into a coherent summary. Generate answer uses the synthesis to answer the question with a cited source. Compose these into a pipeline module. Each node calls the next with the output of the previous. Your forward method orchestrates the flow. Now, the optimizer. MyPro v2 multi-prompt instruction proposal and optimization is the most powerful DSPy optimizer right now. Unlike Bootstrap Few-Shot, which only selects examples, MyPro also optimizes the instruction text itself. It generates candidate instructions using a meta prompt, scores them against your validation set, and selects the combination of instructions and examples that maximizes your metric. Create the optimizer by instantiating dspy.addMyProv2 with your metric and mode set to light for a quick run or medium for more thorough optimization. Call compile with your pipeline, train set, and num trials. Try 20 for a quick experiment, 100 for production optimization. Save your compiled program with pipeline, save optimized pipeline, JSON. Load it later with dspy.load-to-serve in production without rerunning optimization. The saved file contains the optimized prompts and examples. For evaluation, DSPy provides dsep.evaluate. Pass your compiled program, the evaluation set, and your metric function. It runs every example, scores each one, and returns aggregate metrics. Run this before and after optimization to measure the exact improvement. The production workflow looks like this. You collect labeled examples during your beta. Even 50 examples are enough to start. You run DSPy optimization weekly or after every significant dataset update. The compiled program gets saved and deployed. Your prompts improve over time automatically as you collect more data. You stop manually tweaking prompts entirely. Your challenge for this episode, take any LangChain chain you have already built and port it to DSPy. Define the signatures for each step. Create the module. Build a dataset of at least 30 input-output pairs. They do not need to be perfect. Run Bootstrap Few-Shot with random search with your module. Compare the compiled program's accuracy on a held-out test set against your original manually prompted chain. The compiled version wins almost every time. That comparison, documented and measured, is your first real experience with systematic AI optimization. Prompts are code. DSPy compiles them. You now build AI systems that improve themselves from data instead of from your intuition. Episode 10 is the final piece. Graph RAG, when your knowledge needs relationships, not just vectors. See you there.